Have you ever considered how the energy in your morning coffee is related to the energy that fuels our universe? Welcome to a discussion on a fundamental principle of physics, the law of conservation of energy. To put it simply, the law of conservation of energy states that energy cannot be created or destroyed. It can only change from one form to another. Imagine a roller coaster ride. As the coaster climbs up the track, it gains potential energy. At the top, it has maximum potential energy. As it descends, this potential energy transforms into kinetic energy, or the energy of motion. This is a perfect example of energy transformation, one of the key aspects of energy conservation. Now let's talk about isolated systems. An isolated system is one where no energy or matter is exchanged with the surroundings. In such a system, the total energy remains constant over time. But remember, this is an idealized concept. In reality, most systems are closed, allowing only energy exchange with the environment. Energy comes in several forms, including kinetic, potential, thermal, chemical, electromagnetic, and nuclear energy. Each of these forms can transform into another, making our world a grand stage of energy transformations. The principle of conservation of energy has far-reaching applications. It simplifies calculations in classical mechanics, forms the basis of thermodynamics, aids in designing power plants and engines, and even dictates the evolution of the universe. However, remember that in real-world applications there are limitations due to energy dissipation. For instance, friction can transform usable energy into thermal energy, often considered a loss. In summary, the law of conservation of energy is a fundamental principle that states that energy cannot be created or destroyed, only transformed. It applies to isolated systems, where the total energy remains constant. It is a principle that governs everything from the energy in your coffee to the evolution of the universe. And while it has limitations in real-world applications due to energy dissipation, it remains a cornerstone of our understanding of the physical world. Thank you for joining this exploration of the law of conservation of energy. Until next time, remember, energy is always in motion, transforming from one form to another.